Homogeneous differential first-order equation. The first-order differential equation is said to be homogeneous if it can be written in the form the y over the x is equal to the function of y over x, where f is a function of the ratio y over x. Homogeneous equation can be solved using the substitution y equals to v or vx, which reduces the equation to a separable equation in terms of v. So in summary, when you see an equation in the form the y over the x is equal to f of y over x, we can solve it using the homogeneous method by substituting for y equals to vx. So when you do that, you'll be left with a separable equation which can be simplified to get the differential equation. Example 1. Solve the equation above. So at first, if you're to solve an equation under homogeneous, we need to check whether it satisfies the condition, and the condition is that the y over the x must be equal to a function of f must be equal to a function of y over x. So solving this, let's make the y over the x the subject of formula. We have x the y is equal to x plus y dx. Dividing both sides by x and dx, we have the y over the x is equal to x plus y over x. I remember in solving homogeneous equation, anytime we see y, we substitute it for vx. So from this equation we can see that the y over the x is actually a function of y over x, because we have y at the numerator and x at the denominator. So anytime we have y at the numerator and x as the denominator, this is an homogeneous first order equation. So in further simplifying, we substitute the value of y for vx. So we have the vx over the x is equal to x plus vx over x. Further simplifying, dvx over the x is equal to x1 plus v over x. So we have the differential of vx with respect to the x, and this is a product rule function. So we're going to differentiate it using the product rule, and in doing so we have v dot 1 plus x dv over the x. If you're confused about this, you can revise back to your product rule and refresh your memory on that. So it's equal to, here this cancels this, so we're left with 1 plus v. Okay, we're left with 1 plus v. So simplifying further, we have v plus x dv over dx is equal to 1 plus v. Making v the subject of formula, we have, making x dv the subject of formula, we have x dv over dx is equal to 1 plus v minus v. So we're left with x dv over dx is equal to 1. So we have that x dv is equal to dx. Dividing both sides by x, we have dv is equal to dx over x. So from this we can see that from the definition above, we said when solving a homogeneous equation, it's going to lead us to a separable equation. So here we can see that dv is equal to dx over x. So this is a separable equation. I have a video on separable equation. I'll put it in the description below. So in solving this, we're going to integrate both sides. So we have v is equal to ln x plus a. A here is a constant. Anytime you're differentiating, you're integrating, we need to add a constant at the end. So further, we have, okay, remember that we said y is equal to vx. So what we're going to do, we're going to resubstitute the value of v, and v is going to be y over x. So substituting the value of v, we have y over x is equal to ln x plus a. Therefore, y is equal to x ln x plus ax. So this is our final answer. Solve xy y prime is equal to x squared plus y squared. So remember, in solving any equation, it is best to make the first derivative, the y over the x, the subject of formula. So in this question we have xy, and remember that y prime is also another name for the first derivative, which is the y over the x is equal to x squared plus y squared. Dividing both sides by xy, we have the y over the x is equal to x squared plus y squared over xy. So let's go over to substituting the value of y for vx. So we have the vx over the x is equal to x squared plus vx squared over x vx. So anywhere you see y, you substitute it for the value of vx. So going further, we have dvx over dx is equal to s squared plus v squared s squared over vx squared. Therefore, the differential of vx, which we did earlier, is v plus x dv over dx is equal to, and factorizing, we have 1 plus v squared over vx squared. So this can go, this can go. We are left with, so taking v over to the other side. Okay, let's continue. X v plus x dv over dx is equal to 1 plus v squared over v. This is equal to 1 over v plus v. Then taking v to the other side, we have x dv over dx is equal to 1 over v plus v minus v is equal to 1 over v. We are left with x dv over dx is equal to 1 over v. So cross multiplying, we have x v dv is equal to dx. So dividing both sides by x, we are left with v dv is equal to dx over x. So we have gotten our separable equation. Further simplifying, integral of v dv is equal to the integral of dx over x. Integrating v with respect to dv, we have v square over 2 is equal to ln x plus a. V square is equal to 2 in x plus 2a. So remember that v is equal to y over x. So therefore, y over x squared is equal to plus 2a. So we have y squared over x squared is equal to 2 ln x plus 2a. So we have that y squared is equal to 2x squared ln x plus 2a x squared. Example 3, we have the equation over here. So remember the first step, make the y over the x the subject of formula. So in doing so, we have x squared plus xy dy is equal to y squared minus xy dx. Sorry, there's a minus here. When taking it over to the other side, so dividing both sides by the y by dx and x squared plus y, we have the y over dx is equal to y squared minus xy over x squared plus xy. So we're going to substitute the value of y for vx. So we have d vx over dx is equal to vx squared minus x vx over s squared plus x vx. So differentiating this, the product, we have v plus x in the v over the x is equal to v squared x squared minus x squared v over s squared plus s squared v. So we are left with v plus x v over the x. Factorizing x squared, we have x squared into v squared minus v over s squared into 1 plus v. Sorry, let's not forget the minus sign over here. There's a minus sign because we carried it over to the other side. So this goes, and we're left with v squared. Sorry, we're left with minus v squared v over 1 plus 1 plus v. So we have v plus x dv over dx is equal to minus v squared plus v over 1 plus v. Taking v to the other side, we have x dv over dx is equal to minus v squared plus v over 1 plus v minus v. So we can do that simply by doing this. So we left with minus v squared plus v minus v. So we're left with minus v squared over 1 plus v. So we have x dv over dx is equal to minus v squared over 1 plus v. Taking x to the other side, or simply cross multiplying, we have x dv 1 plus v is equals to minus v squared dx. Simplifying further, we have dv 1 plus v over minus v squared is equal to dx over x. So we have that dv 1 over v squared 1 minus 1 over v squared plus, or we can just put the minus outside, then we're having 1 over v squared plus v plus 1 over v, which is equal to dx over x. So to simplify this, we're going to take the integral of both sides. That's going to be minus outside. We'll be left with v raised to power minus 2 plus 1 over v dv is equal to dx, integral of dx over x. So integrating this, we have v raised to power minus 1 over minus 1 plus ln v, which is equal to ln x plus a. So we have minus 1 over v plus ln v is equal to ln x plus a. So substituting the value of v for y over x, we have that minus 1 over y over x plus ln y over x is equal to ln x plus a. So we have that minus x over y plus ln y over x is equal to ln x plus a. So we have that minus x over y plus y minus ln x is equal to ln x plus a. So ln y minus x over y is equal to 2 ln x plus a. Therefore, this is trying to tell us that anytime from the beginning we said that a homogeneous differential equation is said to be homogeneous if it can be written in this form. So whenever you see it in the form dy over dx is equal to f of y over x, where f is a function of y over x, it can be solved by substituting the value of y for vx, which reduces it to a separable equation in terms of v.